Hi everybody, Ms. Fennell here today explaining to you a little bit about energy transfer in ecosystems. And to transfer energy between living things in ecosystems, we have food chains, food webs, and then explaining how all that energy transfer happens, we have energy pyramids. If you want to look at the book pages for this topic, it's pages 43 to 47 if you have a paper book. Otherwise, you can click this link and that will take you to the book pages that are explaining the same things I'm talking about here today if you want more information. So first we need to start with when we talk about energy in foods in ecosystems, almost all food chains on planet Earth start with plants. Almost all. There are a very few exceptions. There are a couple of really weird food chains deep in the ocean that start with something that does chemosynthesis instead. But for our practical purposes, things you've seen in life, almost all food chains, practically all food chains, start with plants. And of course, what we have plants is plants get their energy from the sun, right? So you have plants that are having solar energy that kind of rain down on planet Earth every day. And we have plants of various kinds that are taking that solar energy and converting it into sugar energy. So plants take the solar energy from the sun and turn it into chemical energy in sugar. They're actually making their own sugar by a process called photosynthesis. In elementary school, you might have learned that photosynthesis is plants making their own food. We're going to step it up a level here in seventh grade, and the type of food that they're making is a chemical called sugar. And so they literally have the ability to take sunlight energy and turn it into sugar energy, which is kind of crazy if you think about it. And so almost all food chains are going to start with some kind of a plant that's doing the process of photosynthesis. We will learn more about photosynthesis later on this year when we study plants in a little more detail. But what you need to know about photosynthesis is that the plant takes in CO2 and H2O. CO2 is carbon dioxide and H2O is water. And so the plant is taking in carbon dioxide gas through its leaves and it's taking in water through its roots. And then it is using the energy in sunlight. We're writing a chemical reaction here. So this arrow means that a chemical reaction is happening, but it needs the energy from sunlight to make that reaction happen. And literally what the plant is doing with the sunlight is it's ripping apart the CO2 molecule and it's ripping apart the H2O molecule and it's rearranging the C's, the carbons, the H, the hydrogens, and the O's, the oxygens, into a chemical called C6H12O6. So it's using this solar energy to rip apart and rearrange carbon dioxide molecules and water molecules, and it's simply rearranging them into C6H12O6. And C6H12O6 is the chemical formula for glucose, which is the simplest form of sugar that we have. This equation, if you are an advanced teacher watching this, especially a chemistry teacher, this might give you the heebie-jeebies a little bit. There's more to it than this, but we are just keeping it as simplified as we can here in seventh grade science. Just to kind of introduce the idea to people that CO2 plus H2O makes, that's what this arrow means, C6H12O6, which is sugar, and then we have oxygen released almost as a waste product here. And so that is a very basic introduction to photosynthesis. We are going to study this in more detail in the next couple chapters. Some of that glucose, some of that sugar that the plant makes is used right away to power the plant, and some is stored in the plant's body. This stored energy is what is available to any animal that eats the plant. So I really like this picture. These bricks would be an example of a plant cell, and then within these plant cells we have the green circles, and the green circles are called chloroplasts, and that is where the photosynthesis is taking place. And so the solar energy rearranging carbon dioxide and water into sugar is taking place in all these little green circles. All the sugar that is made, once again, some of it is used immediately. Some of it is sent to the energy burning part of the cell, and it's burned immediately for energy for the plant. Other sugar, the extra sugar that's made, is stored in the plant's body. And that's what's going to be available. That energy, that sugar is going to be available to any animal that eats the plant. All right. So in a food chain or in an ecosystem, we have these very important organisms, these very important living things called producers. They do the photosynthesis that starts almost all food chains on planet Earth. If you really want to get down to it, life is solar powered. All of the energy that living things are using, by and large, comes from producers, and all of that energy comes from the sun. So without the sun, life on Earth as we know it, of course, is not possible for many reasons, but mainly because it would if we didn't have sunlight, we wouldn't have our food chains. So examples are all kinds of plants, and of course, algae in oceans and lakes and things are an aquatic organism that also does a lot of important photosynthesis to start our food chains. In addition to producers in an ecosystem, we also have consumers. And a consumer is any living thing that has to get their energy by eating any other living thing. And then within that, we have types of consumers. You have herbivores, which only eat plants. You have carnivores, which only eat other animals. You have omnivores that eat both. We won't get into this too much, but primary consumers eat the plants, they eat the producers, and secondary consumers eat other consumers. So there's a lot of words here. Mostly we'll be sticking with kind of what you used in elementary school: herbivores, carnivores, omnivores. These are all three different types of consumers. They cannot do photosynthesis. They have to get their energy by eating other living things. So this is an example from your book of a very simple food web, or excuse me, a food chain. We have the plants, which are doing photosynthesis, that get eaten by the grasshopper, that get eaten by the fox. So a food chain is a series of events in which one organism eats another in order to get energy. So this is all about energy. And the arrow is going from what is eaten to what eats it, because it's showing the flow of energy in this ecosystem. The producer in this food chain would be whatever plants are here. So this is the producer that's doing photosynthesis and starting the food chain. And then we have the consumers, which would be the grasshoppers and the fox. And the grasshopper would be considered an herbivore or a primary consumer because it's eating the producer. And the fox would be considered a secondary consumer because it's eating the thing that ate the plants. And so those are some of the interactions we have going on in the ecosystem. A really, really important part of the ecosystem, in addition to producers and consumers, we have decomposers. Decomposers consume and eat dead plants and animals and decompose them. And so usually we have things like bacteria and fungus that are known as our primary decomposers. And this is really important. If we had dead bodies of things that have died that didn't decompose, eventually we would run out of nutrients to make new stuff with. So decomposers are known as nature's recyclers. They are taking the nutrients, the atoms that make up the body of dead things, and recycling it back into the environment so it can be reused to make new things. So this is really important. If we could wave a magic wand and get rid of all bacteria tomorrow, wouldn't be a good idea, because bacteria are important for recycling dead stuff back into the environment. And so we really need decomposers in order to do that for us. Food chains are really simple, but in nature, it's really not the way it is most times. Yesterday, we talked about, or hopefully you have learned about, food webs. A food web is made of many overlapping food chains in an ecosystem. You made a food web. I hope you made a food web before today. Once again, the arrows go in the direction of the energy flow. The arrows go from what is eaten to what eats it. All right, so we kind of have arrows going from what is eaten to what eats it, and showing all of the various interactions in the ecosystem. Very last thing for today is this idea of energy pyramids. In most food chains, we don't see food chains getting to be more than 3 or 4 organisms deep. We don't have food chains that are 5 or 6 or 7, and that's because we run out of energy. So if we start with our producers in an ecosystem, these producers are doing photosynthesis and making sugar. Of all of that sugar that they make, they are going to use 90% of it. Only 10% of it is going to get stored in their body. 10% then will be passed on and available to the mice to eat when they eat the plants. So if we start with 1,000 calories going into the producers, of that 1,000, there would only be 100 calories available available for the consumers. From that level, of the 100 calories of plants that a mouse eats, for every 100 calories of plants that a mouse eats, they're going to use 90% of that energy to run around, to wiggle their tail, to do mouse activities. Most of that energy then escapes as heat, and only 10% of the calories are going to get stored in the mouse's body, in muscle cells and fat cells and various things. So of every 100 calories of plants that a mouse eats, only 10% would be available to a snake that eats a mouse. And then of the 10 calories of mouse that a snake eats, they're going to use 90% of that energy, once again, to do snake activities. 10% will get stored in their body. So from the original 1,000 calories we started with, by the time you get up to the owl, we only have 1 calorie left for the owl. And that's why we only have a few apex predators. They generally have a territory that's a large amount of land. They're going to need a large amount of land to grow enough plants, to support enough mice, to support enough snakes, to support even just one owl. In every level, once again, 90% is used, 10% is available for the next level. So all you have to do is move your decimal point to the left one place. We go from 1,000 to 100 to 10 to 1. There really wouldn't be any energy left for a predator that's going to try to eat an owl. So only 10% of that energy is available for the next level. And so we can see several examples of this. Again, 10% of the energy harvested at a lower trophic level is transferred up to the next level. We call these things trophic levels. So if we start with, in this case, 100,000 calories of producers, 90% of the energy they make is going to get consumed by them. 10% is available for the next level, and 10% and 10%. See, we're just reducing it by a zero, moving our decimal place left 1 point. By the time we get to the top, we have very few calories left for the things at the top. And once again, if we started with 90,000 calories of producers here, we'd have only 9,000 available for the herbivores, only 900 available for primary consumers, only 90 left for secondary consumers. And if we had something up at the top here, there'd only be 9 calories left. So that's why food chains can only be of a certain length, because we literally run out of energy. This is also why an ecosystem needs far, far more plants. We need a lot of plants to support even one apex predator. And so because the energy gets transferred and used up, and we literally run out of energy. All right, that's it for today. Thanks for watching. Good luck on your Ed puzzle. Have a good day.